This is KB0ASQ, and this is information on our power management project that we're building right now. This is the first part of the series, and in this part I'm going to go over what our design goals are and what we've done so far, and give you an update on what's coming up. So to start out with, the purpose of this project is to create a power center for my homebrew amateur radio station so that I can control and monitor directly from the front of the equipment or over an IP-based network. I will accomplish that by employing our Arduino microcontroller and other components that we sell at flatwatertradingpost.com. The components in the power management unit are as follows. First of all, we're going to be using a 40 amp switching power supply that I purchased off the internet. It features adjustable voltage. I can adjust it from 12 volts to 14.5 volts. Obviously we're trying to adjust it for 13.8 volts. It also has built-in filtering, and it's got a hiccup mode. It'll automatically reset itself if something happens. Fan is also temperature sensitive, so it'll spin up and slow down based on the temperature of the power unit. Initially I looked at building the power supply myself. I wanted a switching power supply for size and weight reasons. I found some plans on the internet. The closest was a design by Manfred. I hope I don't mangle this last name too bad, but Mornhinweg XQ2FOD. It was published in QST in the December 1998 issue of QST. You can if you're a member of QST, you can download that off the internet. It met all the design specifications that I wanted. However, I decided not to go this route, mainly because you have to wind the main transformer yourself, and I really didn't feel like at this point I was up to that task. So we went this other route, the one thing about the project that I'm doing right now is it's modular in design, so later on if I find a design I like or decide I want to tackle the other one, I can pull the switching power supply out and replace it, with whatever I come up with. Okay, the components in the power management unit, like I said, obviously the first one is the power supply. The next one, I'll show you here in a little bit, is an Arduino Mega 256 board. I'll be using it to control the other components in the power management unit. I've written most of the code and will post it on the website as soon as I've finished it. Then we have a 5-volt power supply that I built on an experimenter's board. The 5-volt power supply that we're going to be using is mainly to drive the Arduino itself, the 5-volt relay board that we'll show you a little bit later that we're going to use to control the ports, and the backlight of the LCD display. The other component, as far as the Arduino, I also have a Ethernet interface board that we're using, and then we're using the LCD to display information about the output voltage of the power supply and current and so on and so forth. We also have a divider. Divider network, voltage divider. So that we can measure that we have to use to interface the Arduino board. Since the Arduino board's 5 volt, it can only read up to 5 volts. So the front panel will consist of an on-off switch that you can see here. I'm kind of partial to green, so we're going to have an on-off switch. the LCD display, which I've got on the breadboard right now. I'll show you here in a little bit. Then we'll also have 4 momentary switches that I purchased here. We're going to use that to turn on and off the ports, and then we'll have some 4 LEDs on it to show you the status of each port. The back panel will consist of a power cord plug. You can use a standard power cord off of a old PC. We're going to have a fuse block here. I'll have a fuse for the power supply itself, the 5-volt power board, and then each I'm going to have 4 output ports. Each one of those will have its own fused output. And then finally, we're going to be using this with some power poles, and that's how we're going to put the for each port. We'll have a set of power poles for each port, and then we'll use this to hold that into it. Okay, later on here in the video, I'll show you the breadboard that we have set up for the Arduino and the 5-volt power supply, and then I'll also show you the web interface that I've designed for. The next video, next part of the video series, we'll go ahead and start laying out the front panel and the back panel, cut them out, get components mounted so that we can start assembling things. Okay, here's the breadboard version of our power management unit. To the left you can see the Arduino 256 Mega with the Ethernet shield on it. Then you can see the LCD, and then down at the bottom you can see the 4 relay board that we're going to be using to control to turn the power on and off in this project. I don't think I can get a good view, but that's the LCD. One of the things that we're going to do is I've got a error message on it if the voltage drops too low. I'm still working on the voltage divider circuit to get it to read correctly. But anyway, I'll have the wiring diagrams up on this when we get it completed. The other thing that we're going to use is we're going to use a device to check for current. I'll show you that in a later episode. And then on my monitor here I have the Arduino screen, or the Arduino IDE that I'm using to program this. Then the other thing that I have, I'll show you here, is this is what the interface is going to look like here. Now I've got some antivirus software running on this computer that's slowing everything down, but I'll kind of show you. You'll be able to click on this button to toggle it. It's kind of running slow because of that antivirus software, but if we give it a second here, there you go. It shut it off. If you notice down here on the board down here, one of the LEDs is off now, so that relay's been turned off. I can turn it back on like that, or I can shut them all off at the same time and then turn them back on one at a time. The response is a lot faster now. And then you can also notice on there that I've got the output. Again, the voltage divider and the current coding isn't all right, but again, you know, we have source voltage is okay. Once it drops down, it'll warn you remotely that the voltage is low. So that's the gist of this project right now, and I'm going to go ahead and sign off. This is KB0ASQ signing off until next time.